Our name is Dan. We work at the Atlassian security team over in Sydney. We're going to be talking to you today about breach detection at scale with AWS Honey tokens. I'd like to say I really appreciate you all actually being here and not in the reception drinking free beer right now. We will understand if you have to leave. So we're just going to start with what we hope are the two stupidest things you see at this conference today, at least on stage. Anything you see at an after party is your own business. Okay, where are we? Okay, so what I'm about to do is generate an annotated AWS credential. So the location that I'll store these credentials will be on screen at a security conference. And the owner of these credentials will be anyone in the room, I guess. Okay, ideally, well, there we go. Okay, so these are some live AWS credentials. You can use them if you like. I'll just demonstrate that they're live. Surely the camera's got it.
And what are you doing now, Dan?
I'm just checking that they're actually alive. Once I can remember how to spell. Let's see. All right, cool. So you can see these are some live creds. They're for a user in the Space Crab group. The user is called 8839 something. Cool. But yeah, don't worry about writing those down because we're now going to do the second and dumber thing and just put them on Pastebin. Let's go. All right, so that'll be on Pastebin's recent paste feed for the next 15 minutes. If you want them, they're yours. Okay, we're doing a talk. We should probably do the talk. Over to Dan, who's going to explain what we're actually doing with our lives.
I might come over here. So how many people in the room are familiar with Honey tokens? Okay.
Tough crowd.
Tough crowd. All right, this is not a Honey token, it's a Honey coin. It could be a good investment, but I probably suggest you don't buy it. But if you want to send me money anyway, that's fine. You can go ahead and do that. What is a Honey token? So a Honey token is just any form of credential or thing, a resource that you use that you do monitoring and logging on, but doesn't exist anywhere else in practical terms. So in general use, they won't exist. So a Honey token can be anything from an email address that doesn't belong to anyone and is just generally available. It can be a DNS name that no one should ever resolve. It can be a URL that no one ever visits. But generally anything that in practice in the real world doesn't get touched only gets touched when, say, an attacker finds it and thinks it's a little bit weird. Sorry, we're just having some trouble with the
slide
speaker notes.
They're supposed to be down there. Okay.
So AWS keys. So AWS keys are really interesting for a few reasons. First of all, you access the AWS API when you want to do any action in AWS. And that's really nice because the API is globally accessible, internet accessible, it's always on, it's never off. And really to do any action at all, you have to use this API. The keys, AWS keys are generally extremely valuable. So an attacker might find them and they might realize they're the keys to your kingdom. They might control your entire internet infrastructure, for example. And they get generated a lot just in everyday use, right? So as an SRE, you need them to manage your AWS infrastructure. As a user, you need them to log in. If you're doing an integration with a third-party service, the AWS keys are required. So they just exist everywhere. And then they can do pretty much anything. Anything that you can do through the API, which is everything in AWS, the creds can do. And then finally, the last thing is attackers look for these things, right? So whenever some account gets compromised, for example, like when we see a HipChat or a Stride account getting compromised, one of the first things that attackers do is look for AKIA, which is the prefix for most AWS access keys. So what they're really looking for is, how can I get another credential that gets me to pivot to something else, something different, something more? How many of you guys know what this is? Right, it's, we call them scratchies in Australia. Some other places they're called instant lottery tickets. But they have some really nice, unique properties, which are very similar to AWS access keys. That being that in order to find out if you've won anything, like if you've won the prize, you have to scratch the lottery ticket. And so for an attacker or anyone else who finds an access key, what they have to do is, there's no other way to find out if it's useful, if it's in fact the keys to the kingdom as an example, other than to use the access keys. And that's the only way you find out. So you effectively have to scratch the lottery ticket, which is your AWS access key. There's generally no downside to scratching them or using the access key. And the prize for an attacker generally is you can spin up as many EC2 instances as you want to mine Bitcoin whenever you want. Another great property of these things is that they're everywhere. I don't know if you can see that, but they're in places like a text file on your CIO's desktop that says AWS root access keys, CSV, do not delete, super important. Or wherever else you might put them. You might put them in your startup variables on a server, for example. Some people put them in their GitHub, their public GitHub repositories, and then find lots of Bitcoin mining going on in their accounts. But they're generally everywhere.
Go to the next slide.
Yep. So I guess the final property that we really care about is that while these access keys might be the keys to the kingdom, they don't have to be. AWS provides a really complex and full-featured policy infrastructure, like access management infrastructure, which means that you can basically say, hey, this access key can't be used for anything. The policy that you see on screen effectively says, for all actions on all resources, we're going to deny access. So so any access key that has this policy basically can't do anything except for one thing. And that's the call that Dan made at the start of this talk, which is get caller identity, which is effectively the who am I of AWS, the AWS API. So you can set this policy, and the other nice thing that'll happen is AWS has a full-featured logging capability, and so all of these deny or allow actions will get logged, and then you can do something with them. So going back to our scratchy metaphor, we have a few, the properties that we care about. The access keys are really valuable. They're ubiquitous, they're everywhere. Attackers will find them, so they won't think they're weird. And they're really easy to secure and have a really detailed logging infrastructure. So the only difference now, if we make them honey tokens, is effectively that instead of the prize being you get to mine Bitcoin everywhere if you scratch the key, the prize is, for it being a honey token, is that you get caught. So that's nice for us, but not so nice for the attackers. Okay, so this is really nice. If you want to generate a single access token and put it on your CISO's desktop, there's a really easy way to do that. A company called Thinkst has provided a free-to-use website called Canary Tokens, and you can just go there, type set AWS access key, type in some metadata about it, hit the generate button. It'll give you an access key and you can put it on your CISO's desktop. That's really nice. You can do the same thing for other types of honey tokens, like the ones we mentioned before, like a Word document, DNS hostname, URL, and that kind of thing. This is really great for when you want to do individual instances of Honey tokens. But you might have noticed that the talk of our title was breach detection at scale. So obviously one-off instances is kind of not what we want. So what if you want to do this on thousands of machines, or you have thousands of managers in your company and you want to place a Honey token on each of their desktops. So before we looked into this, there was no real way to do this at scale.
So in order to address these scaling problems that we were running into, we made Project Space Crab. And for the avoidance of any doubt, Dan has a very important thing to say about Space Crab.
You'll notice that the crab is not in space. The space is inside the crab, and it's very important.
I don't know, I just work here. Okay, so Project Space Crab is an AWS CloudFormation stack. CloudFormation stack is just a set of instructions that tells AWS what to do. It deploys a couple of things that we care about. The first one is a data store, which we use to store the annotations that you saw us adding to credentials earlier. Some policies, including the deny all token policy that you saw on screen before. Some lambdas, lambdas are just Python scripts that AWS runs for you. An alerting pipeline, and an API gateway. The API gateway is just a HTTP wrapper in front of some of those lambdas. So excuse me, Space Crab lets you make annotated AWS keys that have no access to do anything at scale. So the pieces of metadata that we collect are like the location, so where it's being stored, the owner, so whose problem is it if somebody uses this token, and any miscellaneous notes. You saw that earlier in my demo. All the keys get the deny all policy, as we mentioned. If anyone ever tries to use one of those credentials, all of those actions get logged into an S3 bucket. And then one of the many, many lambdas that we've written processes through that log, looks for keys that it knows about, and if it finds one, grabs the extended metadata attributes from the data store and pushes them into an alerting pipeline. That alerting pipeline is basically on the edge there, another couple of lambdas. You can use those to send yourself an email or send an email that goes into your ticketing system, or page you on PagerDuty, or really anything else that you can write a Lambda function to do. We haven't written any more alerting options because those are the ones that we want. But if you would like to have a different alerting thing, this is an open source project. You can contribute to it today. Once you've generated the stack, you can generate up to 10,000 tokens. The reason for that limit is that AWS has a per account user limit of 5,000 users, and each user can have 2 tokens. We asked them, can we get more users? Can we get more tokens per user? And they laughed at us and told us to go away. So if you need to generate more than 10,000 tokens, you'll need to spin up a second AWS account. But 10,000 tokens is enough to cover your fleet of workstations, or microservices for your cloud service that you run, or to put an individual record in everybody's online password saving service that they use, or your third-party logging analytics. Okay, so you might have some questions about this, and we're going to just do a little Q&A here. We'll try to head off any of the questions that you might have. So,
this one's mine, Dan. Deep artificial intelligence powered by machine.
Hang on.
You getting a call?
I'm currently being paged, and also we promised not to do any thought leadership. Let me just.
PagerDuty alert. You have one triggered incident on Space Crab talk.
So that's exciting. I should look at this.
AWS token of XPSOE 6DTMC4 has been used from source IP 66.96.209.89. Press 4 to acknowledge. Press 6 to
Yeah, okay. Thank you, PagerDuty, for informing me that I used my token earlier today. Sorry, I'm just trying to get to this second tab, but I cannot find the mouse. Where is it? There we go.
There you go.
Okay, just so for an example, if I reload this, there will be a PagerDuty incident. Right, so that's resolved. So you can see here the notes that I put in. Hi, Mum. The action that I took with this token, and the user identity, principal ID, the metadata that we added to that thing, and the source IP address, which is an extremely useful thing to know if somebody's touching your infrastructure. Okay.
All right, back to the thought leadership. I wasn't finished down.
Let's just skip to the next one.
All right. All right, so how do I set up Spacecrab?
Okay, setting up Spacecrab is fun and relatively easy. Go to this URL, clone the repository, and basically follow the instructions in the README. The slides will be up later, so don't worry about writing stuff down unless you want to. So inside the repository, there's a script called manager.py. It asks you a bunch of questions like what's the AWS user who owns this? What's your PagerDuty events key? Fill out those things and wait about 45 minutes and the stack will get spun up, and then you will have a functional deployed stack.
All right, so if I've deployed the stack, how do I generate tokens to put them somewhere?
That's a really great question, Dan, and I'm glad you asked. It depends entirely on your infrastructure. So if you have a fleet management interface for your workstations, like Casper if you use Macs, or a bunch of PowerShell scripts and some GPO stuff if you run Windows, you can get those to run a script that pulls down credentials from Spacecrab and stores them somewhere on disk. So here, which is entirely unreadable, sorry about that, is a bash script that I wrote for Casper to do exactly that thing. It hits an API gateway that you get from the Spacecrab stack, generates tokens, stores them on disk. But maybe you don't want to put them on your workstations, you maybe want to put them on your cloud, like your microservices. So you just put a similar thing to this somewhere in your deployment pipeline for your microservices. Or you can write a script to like generate these and email them to your CEO for some reason, or run them through your third-party logging analytics JavaScript that you have on all of your corporate websites for some reason and see who's reading those logs. It's entirely up to you. Patrick Gray has a suggestion. Print them out, put them on a post-it note, and stick them on a monitor for the next time you have a video interview in your room. That's maybe not very scalable.
So, but if we tell people that we're using honey tokens, doesn't that make them useless, Dan?
I mean, probably not. If a red teamer, or God forbid, an actual hacker finds some credentials lying around on your CISO's desktop and doesn't use them because they're afraid they're a honey token, then you win, basically. It's not what you wanted those honey tokens to do, which is tell you that that person is there, but you still win if they walk away from valid credentials. So here's Shubs, one of our Australian bug bounty kings, who is terrified of honey tokens, which is fantastic. All
right, Dan, I'm a manager. I want to know how much this thing costs.
That's a very important question. So our enterprise scale Spacecrab deployments cost between $200 and $300 a week, which I think is under even your purchasing limit.
Yeah, for beers.
Yeah. Okay, so once you've deployed Spacecrab and you've effectively secured your perimeter, you've secured your squishy inside bits as well, you'll have a lot of free time on your hands and you'll probably get bored. And you might want to know, what do people actually do with leaked credentials if they find them on the internet? So we set up some infrastructure to test this because, again, we had a lot of spare time. We spun up a separate AWS account that didn't have any of our production data in it. It's probably a good idea just generally. And we ran a little script in that every half an hour. And the script would go to Spacecrab, generate a token, and then put a token in GitHub gists or in a GitHub repository, or finally on Pastebin. So the first thing that we learned when we started doing this is that AWS monitors GitHub public repos very closely. If you put a lot of keys in your public GitHub repos, AWS will open a lot of support cases about the keys that you put in your public GitHub repo. They do that about 30 times per account before they basically write you off as an idiot and stop doing that. The second thing that we learned is that if you ignore those support cases for long enough, someone from Seattle will call you the day after Christmas at their time to say, hey Dan, what are you doing with all these compromised keys? And when you say, oh no, it's fine, I did it on purpose, I want those to be there, they say, okay, thanks, I'll have to get back to you. And then the third thing that we learned is that posting hundreds of keys to the internet is against the AWS terms of use, and we have to stop. So we unfortunately could only run this experiment for like a week and a half before we were told to, delete your account, basically. So yeah, we didn't run this for as long as we wanted to. I also like to say that all the people I talked to at AWS were like super useful and super helpful, and thought that this research was cool, and also that I should stop and delete my account. So in our sadly truncated research, we found that there are exactly two kinds of people who use compromised AWS accounts. The first one will find some credentials lying around in GitHub and put them in like a GUI S3 bucket browsing program. And they'll try and list buckets, and when they see that they can't list any buckets, they just give up. So they lack discipline. The second kind will collect all of the credentials that he finds and then put them in a Python script that they wrote and try every API that AWS offers. So they're not necessarily interested in listing buckets or just spinning up EC2 instances. They'll also try and find all of the weird little information disclosure vectors that you might be able to get with an AWS key that they can then use to spin up EC2 instances and like mine Bitcoin. There might be other types of people if you run this experiment for more than a week, but those are the two that we saw. So here's some exciting statistics. On GitHub, if you post your credentials to a public GitHub repo or to a public GitHub gist, there's pretty much an 83% chance that someone is going to use those. And they will use them 30 minutes exactly after you post them. I have no idea why it's 30 minutes exactly, but it's 30 minutes plus or minus a couple of seconds every time we do this. It's maybe something to do with how GitHub search works, but I don't know. If you have any ideas, please tell me, because it confuses me a lot. On the other hand, Pastebin has a completely different exploitation profile. So only 9% of the tokens that we stored on Pastebin actually were attempted to be exploited. And that's a better hit rate than I've had in some commercial secret storage services that I've used personally. So Pastebin is a great place to store your secrets. So Pastebin pastes also just have a different exploitation profile generally. When you post something to Pastebin, 50 or 60 IP addresses around the world immediately scrape that because they're constantly scraping the front page of Pastebin. But if it falls off the front page, you basically can't find it for generally about 15 days because Pastebin only updates its paste to Google search like once a month or so. And people are grabbing these immediately, but they're not acting on them as quickly. So with GitHub, you post it, someone uses it immediately, they're done. But with Pastebin, we saw times between a little bit more than 12 hours up to nearly 2 days later before somebody actually tried to use them. Which means that if you're in a competitive intelligence thing, there's probably a market gap for scraping stuff on Pastebin and telling people about it. Free product idea, go for your life. Okay, the most secure place that I found to post credentials on the internet is just put them in a picture on Twitter. I put the words unhackable infrastructure in a tweet and nobody cared enough to like look at it and go, Dan, your C code is awful. There are like 6 different RCEs right there. And also there's like an API key right at the bottom of that picture, which I personally found extremely disappointing. But if you need to store something secret, put it on a low traffic Twitter account. Okay. We do not have a strong finish, unfortunately, but we do have some calls to action. The first is use honey tokens, put them around your network. You'll learn horrible things and it'll be fun, and it's mostly pretty easy. And also, please contribute to SpaceGrab. It's an open source project. It's on Bitbucket. You can fork it and give us suggestions for making our JSON less horrible. Or add new alerting mechanisms if that's something that you're interested in. Thanks. Does anyone have any questions, or everyone wants to go to the reception and drink the free beer? Okay, I'm with you.
No, thanks everyone.